Ever wonder what it takes to really protect a town from nature's power? Today, we're looking at the Lower Var River Valley in France, specifically the reinforcement of the St Laurent du Var Dyke.
hmm It's a pretty significant project.
It really is. We're talking about protecting nearly 2,000 people, plus an industrial park, the town center, basically guarding against major flood risks.
Yeah, and this was all driven by the official flood risk prevention plan. They knew they needed stronger defenses along about 1.6 kilometers next to the main road there, number 95.
And the core solution they went with is this double sheet pile wall system.
Exactly. A really interesting engineering choice.
It sounds complex, not just a simple wall. And we should mention the steel sheet piles themselves. They came from ArcelorMittal.
That's right.
So our mission today is to dig into why they chose this method and what advantages these steel sheet piles really offer for, well, such critical infrastructure.
Okay, so to get why this upgrade was needed, you have to look back a bit. There was already some protection in place. This was part of the Flood Prevention Action Program, the PPI. Phase 1, basically.
Right, so defenses existed. What level were they designed for?
Initially, they were built to handle a flood flow, Q they call it, of about 3,800 cubic meters per second.
So why the big reinforcement project then?
Well, in 2011, an updated risk assessment came out, and it painted a much more serious picture. The new requirement was for defenses to withstand a flood of 5,000 cubic meters per second.
Wow, that's a huge jump from 3,800 to 5,000.
Exactly, a massive increase. So the existing dike just wasn't sufficient anymore for this newly understood risk level. They needed to reinforce another 1.1 kilometers quite substantially.
Which brings us back to the double sheet pile wall. Was that the plan for the whole stretch?
Well, specifically in the areas where they actually had enough space on the bank, that's where they opted for the double wall design.
Can you describe that a bit more? What does it look like?
Sure. So imagine two parallel walls made of these interlocking steel sheets, driven deep into the ground. The main wall, the one facing the river, used ArcelorMittal's AZ-23-800 piles. Pretty substantial, like you said, 12.7 to 14.5 meters long.
Okay. And the second wall?
Behind that, acting as an anchor, they used AZ-18-800 profiles, shorter, between 2.5 and 7.5 meters long. And both types were made from a specific steel grade, S355 GP, known for its strength.
Sounds incredibly robust. Do you know how much steel that involved in total?
Oh yeah, it was significant. 2,315 tons of ArcelorMittal steel sheet piles went into this part of the project. And these two walls, they were installed about 12 meters apart.
12 meters, okay.
Yeah, and then they used tie rods installed every 1.6 meters or so, linking the two walls.
Ah, so that connection makes them work together as one system.
Precisely. That's what gives it its real strength. They act as a single, incredibly sturdy barrier.
Okay, so let's talk advantages. Why steel sheet piles specifically for this kind of flood defense? What makes them so effective?
Well, the key thing about steel sheet piles is how well they resist both overflow water coming over the top and, crucially, erosion. Think about that 5,000 cubic meters per second number again. That's immense force. You need something that won't just wash away or, get undermined.
Already needs to stand up to that pressure.
Exactly. So this reinforced dike, thanks to the steel piles, is designed to stay stable. Stable against erosion from the outside, from the river currents. Stable against internal erosion, water seeping through. Stable against overflow, and just overall structural stability during a really big flood.
So it's about total integrity under extreme stress, not just blocking the water.
That's it. And the choice of those specific ArcelorMittal AZ profiles wasn't random. Using different lengths for the main and anchor walls, that shows, careful engineering.
Yeah.
Tailoring the solution to the exact forces and ground conditions along that stretch.
Makes sense.
Plus, that S355 GP steel grade gives you the high strength you need, but also long-term durability, essential for infrastructure like this. And interestingly, there was also an optimization. They actually managed to use a slightly lighter profile, the AZ-23-800, instead of the initially planned AZ-24-700.
Oh, really? Without compromising strength?
Apparently so. It was equivalent in performance, but lighter, which led to around 14% savings, so cost-effective too.
Efficiency and cost savings, always good to hear. How complicated is it to actually install these massive sheets?
They adapted the method. For the long main wall, they used something called panel driving. You install several connected piles together, speeds things up. For the shorter anchor wall, they used pitch and drive. That's more like installing them one by one. Place it, drive it, next one.
So flexibility in the installation.
Yeah, and importantly, they monitored vibrations the whole time, to minimize impact on nearby areas and structures.
Sounds very thorough. Careful planning. So when did all this happen? What was the timeline?
The actual riverbank reinforcement work kicked off in July 2016, and it was all completed sometime in 2017. Pretty efficient, really, for the scale.
Okay, so let's quickly recap the benefits here of using those ArcelorMittal steel sheet piles. We're looking at much higher flood protection level.
Yeah, up to that 5,000 meter level.
Right. Enhanced stability against all sorts of failure modes, erosion, overflow.
Definitely. Much more resilient.
Potential cost savings through that smart material selection, the optimized profile, and the use of specialized engineering and adaptable installation. It really seems like a strong case study for modern materials and infrastructure.
It really is. It shows how important, good engineering and the right material choices are for building infrastructure that lasts and protects communities.
A really insightful look, thanks. It definitely makes you think, as we face more extreme weather and environmental challenges, what other kinds of innovative materials and solutions are out there or need to be developed to keep our communities safe and resilient? Thanks for digging into this with me today.